Welcome to the next lecture of the CBNST. In today's lesson, we will talk about solution of simultaneous linear equations, and we'll see the method Gauss Jacobi to solve these simultaneous linear equations. This Gauss Jacobi method is also known as Jacobi iterative method. So let us see what we mean by simultaneous linear equations. So linear equations which have the power 1 of the variable. So equations like a1x plus b1y plus c1z is equal to d1, where a1, b1, c1 and d1 are all constants. So if we have a system of these equations, let's say in this we have 3 such equations. So this system is known as the system of simultaneous linear equations. If you want to solve these equations and we want to get the values of the variables x, y and z, then we need to follow this Gauss Jacobi method. We have other methods. We will study those methods also in the upcoming lessons. So let's see how this Gauss Jacobi method will give us the solution. Let a system of linear equations be a1x plus b1y plus c1z is equal to d1. This is the first equation. This is the equation number 1. And then the equation number 2 is a2x plus b2y plus c2z is equal to d2. Similarly, the equation number 3, this is the a3x plus b3y plus c3z is equal to d3. The primary condition to apply this Gauss Jacobi method is that this system must be diagonally dominant. What we mean by diagonally dominant? Diagonal dominancy means the mod of a1 should be greater than the mod of b1 plus mod of c1. That means in the first equation, the value of a1, the absolute value of a1 must be greater than the sum of the absolute values of b1 and c1. Let me give you one example. For example, if we have the equation, let's say 10x plus 3y minus 4z. This is equal to, let's say, 0. So what is a1 here? a1 is 10. What is b1? b1 is 3. And what is c1? This is minus of 4. The absolute value of a1, this is a1, this is equal to 10. Absolute value of b1, this is 3. And absolute value of c1, this is 4, because in the absolute value we do not consider the signs. So now if we'll apply into this, so we can see that 10 is greater than 3 plus 4. So this is true in this case. So that means this first condition is applicable onto the first equation. Then the second condition will be applied onto the second equation. That means the absolute value of b2 should be greater than the sum of the absolute values of a2 and c2. So let's say if we have the second equation, let's consider any other second equation. Let's say 3x minus 4y plus 3z. Now here we can see the absolute value of a is 3, the absolute value of b is 4 and the absolute value of c is 3. In this case we can see that 4, this is not equal to or not greater than 3 plus 3. So this equation will not satisfy this condition. So let me show you one equation which will satisfy this equation. If I make a simple change, let's say if 3x minus 7y plus z. So now we can see a is 3, b is minus 7 and c is 1. So if we'll take the absolute value and we'll write b1, the absolute value of b1, so that is 7, will be greater than 3 plus 1. This is true. So this equation, such type of equation will be on the the second equation. And similarly in the third equation, the absolute value of c3 should be greater than the sum of the absolute values of the other constants. So this is the primary condition. If any such equation satisfy this thing, then we'll say that this is following the diagonal dominancy, right? So let me give you one example of the diagonal dominancy. Let's say if it is 10x plus 3y plus 2z is equal to 0. If we have 5x plus 15y minus 3z is equal to 0. Then let's say if we have 6x plus 7y minus let's say minus 18z is equal to 0. So in this first equation we can see the absolute value 10 will always be greater than the sum of 3 plus 2, 5. So this is true. Then this 15 is greater than the sum of 5 and 3. We will take the absolute values. This is also true. And in the last equation, this C, that is 18, is greater than the sum of 6 and 7. So we can see that this is the diagonal is dominating. So in any system, linear equation system where this diagonal dominates, on this we can apply the Gauss Jacobi method. Now let's see what is the Gauss Jacobi method and how we can solve this system of linear equation. To apply the Gauss Jacobi iterative method, we must have the initial values of x0, y0 and z0. These are the values of x, y and z. These initial value can be given in your question, or we can assume these values. If these are not given in our equation, then the initial value will always are equal to 0. So x0 is 0, y0 is 0 and z0 is 0. And in many cases these initial values are given into your question. So using with these initial value, first we have to convert these three equations into some other form. Let's say from the first equation, as we can see that this term is dominating, so we'll find out the value of x. So if from this equation we need to find out the value of x, so this x will be equal to, let's say this is d1 minus b1y minus c1z, and this constant term will come this side and we'll divide this whole term by the constant term. So let's say this x is equal to 1 upon a1. This is the first equation that we achieved from equation number 1. From the second equation we will find out the value of y, right? Because in this term is diagonally dominant, so we will find out the value of y. So y will be equal to 1 upon b2, this is 1 upon b2 d2 minus a2x and minus c2z. So this will be our second equation. The third equation we can achieve from this third one, and from this we will find out the value of z. So what will be the value of z? So this is z is equal to 1 upon c3, this is d3 minus a3x minus b3z. So this is the third equation. So these three equations will serve as the formula for the Gauss Jacobi method. Now what we need to do is we need to substitute these initial values into these equations, and we will be able to find out the next approximated values. Let's say if in this first equation instead of y we substitute y0 and instead of this z we substitute z0, so we will be able to achieve x1, next approximated value. In this, if we'll substitute x0 and z0, then we'll achieve y1. In this, if we'll substitute x0, z0, then we'll achieve z1. So we'll have new values of x, y and z as x1, y1 and z1. Then we'll come to the next iteration and we'll again substitute y1 and z1, and then we'll get x2. Then x1, z1, we'll achieve y2. Then x1, z1, and then we'll achieve, so this has to be a3x minus b3y, sorry. So in the last equation, and the third equation can be achieved from this last one, and we can see we'll take this term from here and we'll get the value of this z. So this z will be 1 upon c3, this is d3 minus a3x minus b3y. So this will be the third equation. So these three equations will serve as the solution of, will serve as a kind of Gauss Jacobi method. So now we need to perform iterations with these methods. Let's say with the initial values we'll substitute in this, and in the first iteration we'll substitute these x0, y0 and z0 in these equations. So let's say if we substitute y0, z0, we'll be able to achieve x1. We substitute x0, z0, then we will get y1, and if we'll substitute x0, y0, then we'll get z1. So we have got new set of approximated values x1, y1 and z1. Now again these values will be substituted and then we can achieve x2, y2 and z2. So y1, z1 will give us x2, x1, z1 will give us y1, x1, this is y2, x1 and y1 will give us z2. So let me show you how this will be working. So let's say to achieve x1, y1 and z1, we'll have to substitute y0, z0. To get y1 we need to substitute x0, z0. To get z1 we need to substitute x0, y0. So these three questions will give us x1, y1 and z1. So this will be our first iteration. Now into the second iteration, what we need to substitute? So we have got x1, y1, z1. We will substitute y1 and z1. We will be able to get x2. Then to achieve y2, we need to substitute x1, z1. Then to need z2, we will substitute x1 and y1. And this way we will get x2, y2 and z2. And this process can be repeated till we get the desired accuracy of the result, or we have performed a number of desired iterations. So let me explain this Gauss Jacobi method with the help of an example. So let us consider this as the system of linear equations and we have to solve this with the help of the Gauss Jacobi method. So let us first check the primary condition of the diagonal dominancy. So in this first equation, as we can see, this is 10, this is a1, so mod of 10 should be greater than mod of this minus of b, this is minus of b, and plus mod of this minus of 2. So this is 5 and 2, only 5 and 2 will be considered 7, 10 is greater than 7. So first condition is true. Then we'll have to check in this second. So this is mod of minus 10 should be greater than this 4 plus mod of 3. This is B, A and C. So here also you can see this is 10, this is mod, absolute value of 10 will be 10. So this is 4 plus 3, 7. Here the condition is also true. In the last equation we'll have to check this z term, so that is mod of 10 is greater than 6 plus 1. So let's say 1 plus 6. Yes, 6 plus 1, 7 is, and 10 is greater than 7. So we can see that the primary condition of the diagonal dominancy excuse me, holds here in this system of equations. So that can be solved with the help of the Gauss Jacobi method. So now let's begin with the iteration, with the first iteration. Now as in the question, there are no initial values of x, y and z are given. So we will take x0, y0 and z0 as 0, right? If it has been given in the question, then we would have been taking those values. So let's start with the first iteration. In the first iteration, we can see that x1, y1 and z1. So what will be the value of x1? We can see these are the equations we have already obtained. So x will be equal to, let's say, 1 upon a1 in the bracket. This is d1 minus b1 y0. This is minus c1 z0. What will be y1? This is 1 upon b2. 1 upon b2. This is d2 minus a2 x0 and minus c2 z0. In the third equation, what is the value of z1? This is 1 upon c3. This is d3 minus a3 x0 and minus b3 z0. This has to be y. So this has to be y. This is y0. Let me correct this, that this is y. Right. So now we need to substitute values into this. As we can see, what is the value of a1? a1 is 10. What is the value of d1? d1 is 3. So let me substitute these values and show you. So let me write this. a1, 1 upon a1 is 10, d1 is 3 minus b1. So what is b1? This is minus of 5. Minus of 5 cross. What is y0? y0 is 0 minus c1. What is c1? This is minus of 2. So minus of 2 cross z0. What is z0? That is 0. So we can see this will term 0 and 0, so this is 3 upon 10. We can say this is 0.3. So x1 comes to be 0.3. In a similar manner, we will calculate, let us say, y1. Let me keep the value of x1 here. So x1 is 0.3. Now we'll calculate y1. What is y1? 1 upon b2. So what is the value of b2? This is minus of 10. d2 is minus of 3 minus a2. This is 4 cross x0, that is 0. Right, and this is minus c2. What is c2? That is 3 cross 0. So now you can see this is minus 3 upon minus 10 comes to be 0.3. So this y1 is also 0.3. Now let us calculate the third variable. The third variable is z1. So how we will be able to calculate this z1? z1 is equal to 1 upon c3. What is c3? This is 10. In the bracket, this is d3. What is d3? Minus of 3, then minus a3. What is a3? This is 1 into 0. Now minus of b3. What is b3? This is 6. So 6 into 0. So this comes to be minus 3 upon 10, and that is z1 is equal to minus 0.3. So this is minus 0.3. So we are done with the first iteration. We have calculated the values of x1, y1 and z1. Now let us move to the iteration number 2, that is second iteration. So let's move towards the second iterations, and now for the second iteration we will find out the values of x2, y2 and z2, for which we will be using the values of x1, y1 and z1. So let's see how we can calculate x2. So this x2 will be equal to, from here, 1 upon a1. So what is a1? That is 10, you can say. Then this is d1. d1 is 3 cross minus of b1. Minus of b1. What is b1? This is minus of 5 cross. Now here we have y1. What is y1? We have calculated 0.3. Then again minus c1z minus, what is c1? Minus of 2. So this is minus of 2 cross z1. What is z1? This is 0.3. So this is the new x2 we have. So we can use the scientific calculator. Let me see what is the value of this x2. x2 is coming 0.39. So this is coming 0.39. So let me write x2. This is 0.39. Now we'll calculate y2. So let me calculate the value of y2. Just to calculate the value of y2, we will be using the values of x1 and z1. So what is y2? Y2 is 1 upon b2. What is b2? Minus 10. In the bracket, this is d2. What is d2? Minus of 3. Then this is minus a2. What is a2? 4 cross x1. So what is x1? 0.3. Then minus c2. What is c2? c2 is this 3 cross z1. So what is z1? 0.3. So in this way we can calculate y2. So the value of y2 is 0.33. So this is y2 0.33. Let me write y2 here 0.33. The same fashion we can calculate z2. So let me calculate z2 for you. Now what will be z2? So z2 will be 1 upon c3. What is c3? This is 10. Within the bracket, this is d3. What is d3? Minus of 3 minus a3. What is a3? That is 1 cross x1. What is x1? 0.3. And then minus b3. What is b3? That is 6 cross y3. What is y3? Sorry, y1. What is y1? 0.3. So this is z2, and the value of this z2 is minus 0.5. 1. So Z2 comes to be minus 0.51. So we have completed our second iteration, and then we can continue with our third iteration. In the third iteration, we will be finding out the values of x3, y3 and z3, and for that purpose we will be using x2, y2 and z2. So this iteration will continue till our desired result of accuracy. You can perform lots of iterations. So in this question I have performed fifth iteration, and after fifth iteration, let me tell you what are the values of x5. What are the values of x5? In the same way we can continue and we can find out the values of x5, y5 and z5. This is the answer of this given system. So I hope so you have understood how we perform the Gauss Jacobi method. In the next lesson we will be studying about the Gauss Seidel method. Thank you so much.